Hello everybody. So today I sound weird or cuz I have really bad allergies and my nose is kind of stuffy, so bear with me. So today we will be determining the length of a parametric curve given by these parametric equations, which is these beautiful parametric equations we have are y equals 2 cosine t and x equals 2 sine t from the interval of 0 to 2 pi, and we have to use this parametric formula here, which is length equals the integral from a to b of the square root of dx over dt squared plus dy over dt squared times dt. So basically all you're doing is, you're going to take a derivative of these parametric equations, square them each, add them, then integrate. But, people have trouble with that. So I'm going to help you with that today. Alright, so let's just get started. Oh, I hate allergies. And I hate this stupid cat. So anyway, it'll be L. And of course, A to B. So this is our A, this is our B. You need the integral from A to B times, no, this pen doesn't work, which is great. So remember that dy, the derivative of y2 cosine t is just negative 2 cosine t. I remember that the derivative of x equals 2 sine t is just 2 cosine t. No, it's 2 sine t. I am going crazy. 2 sine t and 2 cosine t. Okay, got that. And then now just square them. So 2 cosine t squared plus negative. Alright, now we're at this point. So here, at this point, I'm just gonna sort of write it over here. So we know that this is 4 cosine squared t plus 4 sine squared t. And we know if we factor out a 4, let's say we just factor out a 4, we factored out a 4, this is 1. So really, what you have here is the square root of 4. Oh gosh, I wish I had an eraser, but I don't, so I'm just going to use my hand. So really here you have 4, and we know the square root of 4 is just 2. And so the integral, L equals integral from, actually it's 2 to 2 pi, 0 to 2 pi. From 0 to 2 pi, the integral of 2 is just 2t. And using the fundamental theorem of calculus, part 2 I think, part 2, yeah. Plug 2 pi will mean 0, just goes away. So if you plug 2 pi into this 2, into the t, substitute it, it's just 4 pi. And so we know our length of this curve is just, actually 4 pi. It's just, this is really messy and, okay. L is just 4 pi. So that is all for today, because I'm a little drowsy, stuffy right now. So that is how you determine the length of the parametric curve given by parametric equations. So remember, you have to use this formula. It's for parametric. It's for parametric. Parametric, we'll say this is for parametric curves. And basically what you do is you take the derivative of these, because it's dx over dt, dy dt. So, you take your derivative respect to t. So once you do that, you have the intervals, you should be given the intervals. So once you're given the intervals, after that you'll have, you basically do whatever in here. And then once you have 1, 2, whatever, you'll get some number, and then you do the fundamental theorem of calculus part 2, integrate normally, and you get that. So basically, I'm really weird, so I'm just gonna tell you what we did so far. Medicine kind of make me a little weird. I feel weird. So anyway, what we did for this problem is basically we took the derivatives, we plugged it in here, this formula, and we put our intervals, we set it. I set it now. And then after that, we solved it. We got 4 cosine squared t plus 4 sine squared t, and then I factored it out. I factored 4 out. And then we're left with cosine squared t plus sine squared t, which is 1, according to trig identities. 4 times 1 is just 4, so you're left with L equals from the integral from 0 to 2 pi integral of the square root of 4, which is just, the square root of 4 is just 2. So in this case, length equals the integral of some 0 to 2 pi of 2 is just 2t. So using fundamental theorem part 2 of calculus, it's just 4 pi, because you just plug 2 pi into here and you have 4 pi. So that is it for today. Conquer math, and that is how you conquer determining the length of the parametric curves. So I'm gonna go now because I feel really weird because I took some medicine and made me feel weird. So I am going to go now. So leave a comment below telling me what problems I should help you do next, and like and subscribe. And goodbye.